بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على رسول الله صلى الله عليه وسلم. In the name of Allah, the most gracious, the most merciful. Greetings, my dear brothers and sisters. May I introduce to you how to calculate or how to gain a chi-test and a p-value out of Excel. Although I'm going to tell later how to design an ROC curve and gain a p-value also in Excel. Now, let's start by having our study population divided into two groups. Group 1 is suffering from a certain disease, let's say, for example, a heart disease, and Group 2 is not suffering from that disease. Group 1, we recorded whether each and every person data, whether he's diabetic or not. So negative stands for non-diabetic, positive stands for diabetic. So group 1 and group 2, we are going to see if diabetes is relevant to this disease or not. So to start calculating or gaining a p-value, we're going to start that by typing here actual. We're going to type in the actual values first. Then we're going to select 4 cells lateral, 4 cells longitudinal, and click over here to mark the borders. Now we are going to fill in those spaces. Diabetes, this space for group number 1, this space for group 2, and total of both groups. Here's positive, here's negative, here total. Now we're going to calculate how many positives are in group 1. Start here with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So there are 22. And this group is out of 40, so 40 minus 22 is 18. 18 negative and 22 positive. Total of 22 plus 18 is 40. I'm going to calculate the positives for group 2. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14. So there are 14 in group 2 who are positive, and that's a group of 42. 42 minus 14, sorry, 28. 14 plus 28 is 42, sorry, 22, and we're going, that's the total of group 1, and that's the total of group 2. Now going to calculate the total of both groups of both positives. 22 plus 14 is 36, and 18 plus 28 is, now we're going to calculate, that's the whole, this blank is for the whole total of those, and should be equal in both sides, which is 82. That's the actual value. Now after we type in the actual values, we'll type in the expected values. To type in the expected values, we're going to copy what we have done in the actual what you have done, the actual values that we have typed in, copy it and paste it under expected. Now select the middle values and delete them. Now to start doing it, click type equal for now total of group 1 multiplied by total of both groups of positives divided by the whole total equal total of group 1 multiplied by total of negatives both groups divided by the whole total. Total of group 2 multiplied by total of both groups divided by whole total. Total of group 2 multiplied by total of both groups divided by whole total. Now to start getting the p-value, type p-value over here and start doing the chi-square test. Type in equal chi test test, open a bracket. Now select the actual values, comma, then select expected values. Close the bracket, click enter. Now that's the p-value over here, and that's the significant value 0.04 or 0.05. That means that that the diabetes is relevant to this disease, and uh, it's a risk factor for that disease. Now in case we are having numbers, lots of numbers, how could we calculate p-value out of these numbers? Now we are having here the same two groups and same study population. Now we're having here body weight. Is this body weight relevant to this disease or not? So to start doing it or calculating it, we need an extra add-in on Excel known as Excel stat. To get Excel stat, you should download it from their website, which is www.excelstat.com. Download that software and install it, and when you install it, open it up. Okay. Now we're going to copy these values into this Excel sheet of Excel stat. Going to select all of them. And paste. Okay, now we know that group 1 is suffering from the disease and group 2 are not suffering from that disease. Let's replace these names by a sign for a positive, so we're placing in a positive sign. Now we need that positive sign to be in all of them. And we know now that those are the non-diseased group, so we're going to mark them as negative, and we want all of them to be the same, having the same sign. And finally we're going to cut these values and place them below the positive values. Okay, now over here we're going to type in disease whatsoever, heart disease or anything. Now to start calculating or designing the ROC curve, above the above tab over here, we're going to see an XL stat, click it. You're going to find an icon of live, click it. ROC curves. Um, Now here we're going to fill in the event data, which is the disease, but and we by clicking it by marking the column B over here, and the test data, which is the body weight, by marking column C over here. Now for those who that's the type of the test data that you need. If it is greater than or equal to, less than equal to, less than, what I need over here is greater than. Options, that's the confidence interval. It is usually 95%. You could uh, make it whatever you want. Area under the curve, usually I use Hanley and McKnight. And that's the alternative hypothesis, which is the area under curve. You need it not equal to 0.5 or less than 0.5 or greater than 0.5. That's it, I think. Then click OK. Once you click continue, uh, those this page opens up, and it automatically does everything. That's the summary statistics. That's the minimum, maximum, mean, standard deviation. That's the ROC curve. You can copy it and make of it a picture whatsoever. And that's the ROC analysis. And you'll find in bold in the middle, or the threshold that's needed with the sensitivity and specificity. Here we have the threshold is 85, sensitivity is 0.40, that means 40%, specificity 0.83, that means 83%. It's an upper bound, a lower bound of the sensitivity, upper bound, a lower bound of specificity. That's the area under the curve is 0.594. Upper bound is 0.471, lower bound 0.717. The p-value is 0.136. Thank you, and hope this video was useful.